In today's video, we are back to the same problem which was we already solved using recursion. I hope you already watched my previous video, which is again a unique path, and the problem was to navigate from this starting position to this end position, which is 3 comma 3. That problem was solved using recursions. Okay, there are many ways to solve the problem, but in this video we are going to use dynamic programming. Why it is important, why we are using dynamic programming, all those explanation you will find in this video. I hope you able to remember how we solve. It was on the recursion where we are going to make the recursion call at two places, here and here. Why? Because we started solving the problem from the bigger solution, which is 3 comma 3, and this solution is depends on solution of this vertices and solution of this box. That's the reason we are recursively calling two times with parameter m-1. This is the coordination because the row is -1, column remains same, and from the left side row becomes same, column becomes -1. Now, in this example, how we are going to solve is in a reverse way. When I say reverse way, we are going to start from here. Since my problem is to reach into this coordination, but I will not start solving from the actual root problem statement. Instead of that, we are going to solve with a smaller solution. When I say smaller solution, let's say the coordination of this is, to understand, I'm going to say this is 1 2 3. Actually in the Python the index start from 0. Just to understand, I'm taking as index 1 2 3, 1 2 3. Okay, the coordination of this is 1 comma 1 and coordination of this is 3 comma 3. This is my starting position from where I want to start, and this is my end coordination where I want to reach. In the previous problem, we started solving from the bigger problem. When I say bigger problem, actual root problem, which was 3 comma 3. But in this way, the recursion is going to be rapidly increasing from this one and this one. Instead of that, I am going to solve from smallest problem. What is the smallest problem? It is 1 comma 1. Since to start from here, let me write, this is my start position and this is the end position or the coordination to start from here and to reach here. How many ways are there? It is as simple as one way, because I am at this position, I want to come back to this position, so the solution will be 1. I will write the solution in green color. This is my solution. Let me write like this, okay, in the circle. This is the solution to start from coordination 1 comma 1 and to reach 1 comma 1. How many unique path was there? Only one. Why we started from here is this is my smallest problem. Whenever you are going to consider DP, there are two things we need to consider. Every problem is overlapping problem. I will explain what is the meaning of overlapping. Overlapping is the same solution you are repeatedly calculating, recalculating. That is called overlapping. Does it make sense to solve the problem which is already solved? No. Because of that, the DP, consider solving using DP only in case if it is overlapping problem. We'll see in this video. Okay, if it is overlapping problem, then solve once and you can either memorize or you can either tabularization. There are two approaches to solve a DP problem. If you are using optimized recursion, this is not a recursion, this is optimized recursion. Even though you are calling the recursions, but you are caching the result so that if the same problem comes repeatedly, I will get it from the cache. This is called optimized recursion. Second is tabulation, which we are going to utilize to solve this DP problems. In this video, we are considering tabulations. Now, when I say tabulation, the matrix either it can be one dimensional matrix or it can be two dimensional matrix. This matrix represent the solution. It is not a approach. Okay, this is the small solution which I will utilize to solve the next problem. Always remember, DP, every next step is depends on solution of previous step. That's how you are utilizing previous step to make the decision to go to the next steps. These two concepts are very important. Whenever you are going to take a next step, this next step is depends on the previous steps, and the problem you are going to solve in such a way that it is overlapping problem, where you can either optimize using caching or you can tabularize the data. Now the biggest difference is, earlier problem we started from the main problem which is called top down. In the next video I will explain what is the meaning of top down and bottom up approach, but here we started from bottom up approach. Bottom up is the smallest problem we are going to solve, which is not necessary your actual root problem. Root problem is 3 comma 3, smallest problem is 1 comma 1. Now back to the solutions. This is going to be now a DP table. So this is two-dimensional DP table where I have the answers. These answers I will utilize for my next step. Either it can be this one or this one. Even if I am going to calculate for this box, the previous steps I am going to utilize to get the solution of this coordination. This is how gradually, this is a progressive solutions. The meaning of progressive solution is smaller solution, it becomes a bigger solution. This bigger solution becomes part of my final solution. This is called the progressive solution. So three key concepts are overlapping problem statements, and starting from the smallest, and the tabulations. Now this coordination I will utilize to reach here. Let's consider I want to reach on this coordinations. Okay, on this coordination I want to reach. From where I can reach to this coordination, I hope you remember the condition. Condition is either you can move down or you can move right. Only two directions we can move, right? We cannot move on the left, we cannot move on the top. Do you know the reason behind this one is, if we allow all the directions, how many possibilities will be there to start from here and to reach here? Many possibilities, yes. Since we can move like this, we can move any times, because we can move up, down, right, left. So there could be many possibilities to reach here. It is going to be infinite, because let's say I can move like this, I can move like this, I can go back, up, down, then finally reach here. That is the reason they don't allow top movement and left movement. They only allow the right movement and down movement. With this one, either you can reach like this, you can reach like this, or you can reach like this. This is the three ways, and these three ways are from this one. Or you can reach like this, or like this. So another three ways. So total it will be 6 ways to reach on the final destinations. We knows one to one, reach to one to one, the solution was 1. Now we are considering which part, 1 comma 2. How many ways I can reach? Only this way. Even if I go down, then I can go like this, but I cannot move on up directions. So there is only one way to reach here. So again, let me write the solution as 1. So only one ways to reach here. Now move to the next one. In this 1 comma 3, this 1 comma 3 coordination, how many ways I can reach? Only one ways, like this, right? So again the solution will be 1. Solution for 1 comma 1 is 1, 1 comma 2 is 1, 1 comma 3 is 1. Even if you extend the problem statement to 1 comma 10, solution is 1. Even it is 1 comma 100, its solution is 1. That means the first row of my dp will be 1. Now consider the first column. To start from here to reach here, only one ways. I cannot go like this direction because I cannot move on the left. So there is only one possibilities, which is down. So the solution will be again 1. Now to reach to 1 comma 3, again the solution will be 1 because I have only one ways to reach here. So for n given m into n matrix, the first row will be 1, the first column will be 1. That means 100 comma 1, the solution is 1. 1 comma 100, the solution will be always 1. So it is very important to initialize the first row and first column with 1. Now the most important thing is the next coordination. Which next coordination we are going to consider? Now consider this 2 comma 2. This 2 comma 2, how many possible ways are there? I can reach here, right? This is one way, or I can reach here. Only two ways. Now this coordination depends on from where I can come to this coordination, either up direction or from the left direction. So do we know the result of the above coordination? Yes, I know the solution 1. Do you know the left coordination? Yes, I know the solution of this one. So this plus this is going to be my solution, which is 1 plus 1. 1 is coming from here, 1 is coming from here. So how many possible ways are there for this coordination? 2. So let me write, this is 2, and this solution was solution we have taken from here and here. So it was 1 plus 1, it becomes 2. This is what I used to call the progressive solution. When I say progressive solutions, it is building the final solution step by step. So I got a smaller solution. This smaller solution helps me to find solution of my next coordination, solution of my next coordination. Finally this solution will be solution we are taking from this step and this step. So every next step is depends on my solution of previous step. This was my next step, it was depends on previous solution, this and this. So if you take the advantage of this solution and this solution, I'm going to get the final solution of 2 comma 2. In the same way, can we get the next solution? What is that next coordination? This coordination. How we can get the solution of this one? By taking advantage of the partial solution or a smaller solution from the top coordinate and this, and we knows the result of this one and this one. So if you sum up this one, I will get the solution as 3. So for this coordination, it is one solution I am taking from here, and this we knows the solution, so it is 1 plus 2, it is going to be 3. Can you imagine how progressively we are building the solution? Yes, we are close to the solutions. We reach to 1 comma 3. In the same way, can we proceed to the next? Yes. Now the next coordination is this one. So how we can get the solution? By taking the previous step. What all the previous steps? This one and this one. Only two ways I can reach here, right? By the constraint given in the lead code, either we can move right or down. So we knows the solution of this coordination, we knows the solution of this coordination, it is going to be 1 plus 2. So 1 plus 2, it is going to be 3. Now we are very close to the solutions. Move to the next, which is only one remaining, the final solution. Now for this final solution, it depends on the partial solution from this coordination and this coordination. So what would be the result, right? We knows already the result of the top coordination and left coordination. It is going to be 3 plus 3, which is my final solution. So this answer plus this answer, it is going to be 6. This is what it is called a DP table, and this DP table is two-dimensional DP table. Even we can optimize to one-dimensional from memory perspective, but it is going to be complex. First, I want to explain how the DP helps to solve this problem statement. So we got the solution, and we started from where? We started from smallest solution. This is called bottom up approach, because in the bottom up approach we started from smallest solution and finally reaching to the final criteria, which was 3 comma 3. Now we got the solution. Can we cross check and verify this result? Yes. So what is the meaning of this one? So we are considering solution of this plus this. Is it really right? Yes, we can see the result. Okay, let's say I have 3 ways I am coming from here. That's the reason we are saying 3, right? And there are 3 ways I can reach to this one. Because of that, 3 plus 3 we are considering 6. Is it really right? Let me write. Okay, the first thing is this one. Okay, I will mark like this. Second is like this, and the third is like this. Am I right? This is the 3 ways, incoming ways to reach on this final destination. That's the reason this was answer 3, right? So incoming direction will be 3. Now consider this next one is from this direction, only 3 ways to reach on this coordination. Let me take another color. Okay, so can I say the first is this one? This is first direction. Second is this direction, right? Third is I will take as like this direction. That means I have how many ways I can reach here? There are total 3 ways. So these 3 ways plus these 3 ways, the answer was 6. This is what the progressive overlapping solution. So the solution of this is overlapping to reach here, and this solution was keep on getting repeated for how many times? Like this, like this, like this, and like this. This is what the DP is having the answers, smaller answer, smaller answer, smaller answers that build the final answers. Now go back to the programming. Since it was using DP, okay, remember we use a DP strategy. Why we use DP strategies? Because it was overlapping solutions. And out of this DP, which specific strategy we use? Tabulations. Yes, and we use 2D tabulation, and this tabulation is called DP matrix. DP matrix is having a smaller solution that builds the final solutions. And from where we started? We started with a very basic problem. What was that basic problem? I hope you remember. We started very basic. Can a problem be smaller than this one? No, they cannot be smaller than this one. Yes, that's why we started with a smallest problem statement. And the first thing what we did was initialize the DP table with 1. This is 1, repeat for the column, repeat for each rows. What it does was the complete DP matrix is going to be initialized with 1. Do you see the differences? What I told initially was the first row will be 1, first column will be 1, but what we did programmatically was everything we initialized to 1. Does it make any big difference? No. Still my answer was the same, but this is somewhat we are going to override. That's the reason I'm least bothered about the complete matrix was initialized instead of first row and first column. Don't worry about this one. We are going to override the values. Now see this one. We are ranging from each row and each column. Every cell, the DP value is depends on I minus 1. I minus 1 is from the top box, right? I is row, I minus 1 is going to be the top row, and the solution is depends on the left. Left means the row is same but the column is previous column. So let's consider this box, this 3 3, okay, is depends on 2 3 comma 2 2 comma 3. So it is going to be row is same m n minus 1. Here column will be decrease, row will be decrease m minus 1 and n. That's the reason I use the formula I minus 1. Okay, I minus 1 is the row is the top row, that means this is the top box. Ij minus 1 is from the left box. So the solution depends on the left box and top box. If you add, so it will be solution of I comma j. This I comma j depends on this box and this box. So keep on increasing. For now, don't worry about the count. Count, I just wanted to say, okay, how many revalidation of the matrix we are doing. How many times this recursion, which is a two for loop recursion in a for loop, right? And to just to see how many times we are calculating. For example, for 3 into 3 matrix, we already have the answer of this one and this one. So how many ways remaining is 1, 2, 3 and 4. So only 4 times we are going for inner loops. If you want to get the solution of 100 comma 1, no, it will not execute this for loop because it was already initialized the first row and first column. So the count remains 0. Even if you say 1 comma 100 to find the solution, no, it will not go in this for loop. Already we initialize first row with all the columns. Even for the first row 100 columns, the solution was 1, so it will not go in this one. So this is how you can say, yes, I can validate using counter. So counter remains 0 and still you will get answer 1. Finally, I am returning the answer of m minus 1 and n minus 1. Since the indexing is starting from 0, so just for you to understand, I have mentioned 1, 2, 3 so that it will be easy for you. Programmatically, all indexes will be starting from 0. So with this one, finally we are returning m minus 1 and n minus 1 and also the count, whether really we are doing the inner for loops. I hope you got a good idea on the DP, why it is called overlapping, why we use tabulation, what is the matrix of 2D's representation, from where we started with smaller basic problem, and this smaller finally helps me to reach the final destination, which was 3 comma 3. I am getting the answer as 6. And can you see the count here as 4? Yes, because we know the solution of this one. So only 1, 2, 3, 4 times we are overriding the one value which was not correct basically, but we override finally. Right. Thanks for watching this video, and in the next video we'll see with another lead code problem which was important for the product based company like Oracle, Google, Amazon.